All right, hello everyone. So today we're going to talk a little bit how we can sort of hack together a endless scrolling functionality inside Jetpack Compose. Now you can see at the bottom here, as we scroll, once we get to the bottom, there's a little delay, and then we get more. So scroll, little delay, we get some more. Scroll, a little delay, we get some more, right? Now, with that being said, the first thing I want to point out is that I've said sort of hack together because I've sort of hacked this together specific to my project. Specifically, I want to point out this top bar and this bottom bar here. This is actually going to be specific to my project. So if you don't have a top bar or you don't have a bottom bar, things might be a little different for you. And I've hard coded in some values like this item height here and this scaffold top bar height. Again, they might be different for you, so that's what makes it a little hacky. But if things get too different as we're going on, I'll say what's hacky and what you might have to change if you want to implement this inside your OR code, if you're inside your own code. But also, if anyone knows a better way to implement endless scrolling, let me know. Also, one more thing before we get started here, I just want to mention that this is the first part in a two-part series, where the next part, what we're going to be talking about is we're going to implement a Firebase backend, and we're going to, on every scroll, we're going to query and get a paginated query from Firebase. Now, I say that this is simple. This first one is sort of how we get up and going. And we're actually storing all the data inside this simple list here. So not too complicated. But nonetheless, let me just close down this and we talk a little bit about the code. Let me close this here. Right, so for endless scrolling, there are really two scenarios that we need to be on the lookout for. The first one is the user is always shown data. So that is, you think of something like TikTok, right? Upon initial load, there's always going to be something the user can scroll through. And the other one being is where the user might either not, there's a possibility like on initial load where the user is not shown data, or there is not enough data to enable a scrolling functionality. So with that being said, let's go ahead and look at the first scenario in which the user is always shown data. So you can see here, you can sort of ignore all this code. We'll talk about it a little later. You can just see here for that, we just have a simple notes list, right, to store our data. And we have a lazy column, and then we loop through it with this DSL, and we use items. Oh, actually, let me just comment this in here. And you see, we can, well, actually, that means I have to comment out this right here, what I'm commenting out now. This is for that next scenario in which the user may be shown no data. But first, we want to talk about where the user is always shown data, right? So the first thing that we actually have to do, right, we have items, we loop through the list, and then we're just making a simple card here with the text that shows the item plus item. Now, we need to be able to determine when essentially we've reached the end of the lazy column, right? Now, when I say the user is always shown data, I essentially mean enough data to enable scrolling, right? So like TikTok, right? The user is shown enough data to enable scrolling. Now, a very simple and easy way to determine if the user is at the bottom of the data is just by using the DSL language within the lazy column. So we have all these items, right? This will be the list that's shown to the user upon the initial load. And then to determine once we're at the end, we just use this item, which is saying we just want to show a singular item, right? We don't want to do any sort of looping like this items. We just want to show a singular item, right? So we can then show circular progress indicator, right? So this, due to the nature of lazy column, this item here is only going to get instantiated and created once we've scrolled through all the items inside our item, right? That's what makes it so much efficient, right? If things are off screen, they're destroyed. If things are on screen, they're created, right? It saves resources that way. It's very efficient. So essentially, once we get to item, we've determined that we're at the end of, we've scrolled through all the items, right? And then we can show the circular progress indicator. That's what we saw, that little black round loading thing. And then we get to this launch effect. Now, the only reason we're using launch effect is essentially because we've got, we are adding to this list, and we're adding to this list specifically because it uses the remember API, which technically makes our composable stateful, and it's being observed, and adding to it is by definition inside the documentation. It says that that's a side effect, and be able to use side effects, we need to use launch effect. So right, then we have this delay, which is just to simulate a network request. Now in the real world, right, and in the next tutorial you'll see, this notes list will be added to a view model. So we actually won't need this launch effect at all. We could just delete this. In the next tutorial you'll see how we actually implement it properly. But if you're going to do it in your own, we don't need that launch effect. You could just go, you have your view model, and then we go, have a method that makes the network call, right? Pretty simple. With that being said, let's just get back into it. Right, so again, that's very simple, at least the simplest way I found, right, to determine that the user is at the bottom. But where this runs into issues is that what happens if there is, something like this where there is no data upon initial load, right? That means that there is no scrolling, and that means on first load, this item will get called. And what that's going to happen is it's just going to be a continuous network call, right? If you have a network call in here, it's just going to keep calling and keep calling and keep calling and keep calling. Which, if you're making network requests, that, can cost you a lot of money. So to fix that, we run into this, or we head into this second scenario in which the user might not be shown either no data or not enough data to enable scrolling, right? And I said that this is kind of where things get hacky. This is where essentially we have to determine if the user is able to scroll, how much screen is shown to the user, and so forth. Ultimately, it's a little confusing, but hopefully I've made this diagram to enable to hopefully better walk through both you and I into determining if we need to run and make our request or not, right? So for that second scenario, there's really two main steps. The first one being is we need to get the height of the lazy column shown to the user. Now what I mean is we need to get the total screen height, and then we need to take the top bar. We need the height of the top bar. Remember I said my scaffold, it has a top bar and a bottom bar. So we need to take the height of the top bar. We need to add it to the height of the bottom bar. And we then need to subtract that value from the total screen height. And that remaining value will leave us with the lazy column visible to the user. Again, a little confusing, but all it really is to get all that is just 6 variables. So we scroll up here, you can see we have this right here. Oopsie. It's all this right here, right? So we get the total screen height of the device through the screen height.db. We store it in this variable. We then get the scaffold bottom bar height through paddings.calculate bottom padding. Now this is given to us here through the paddings value, which is actually provided to us by the scaffold itself. So it allows us to dynamically calculate the height of the bottom bar, which is really nice. However, with the top bar, to get the actual height of it, I had to go through some trial and error. So again, this is another sort of hacky bit that isn't fantastic. We need to get that height. So this is something that's going to be different, probably different for you, but through trial and error, I found that my top bar is roughly around 100 dp. So right, then we get the screen hidden by those bars. We add the bottom bar height, the top bar height, and we get the total. And then to get the screen that's actually visible to the user, we take the screen height and we minus it by the screen hidden by bars.value, which is going to give us a float, which will give us essentially the what's shown to the user. So this variable in this line of code here is going to give us this value here, this nice little white bar, or this nice little white section. And that ends for step 1. Now for step 2, if we actually, let me just get back to our diagram here. Now for step 2, what we actually need to do is we need to determine if the lazy column items, so this is a lazy column item, so we need to determine if the lazy column items, if their combined height exceeds the height of the lazy column shown to the user. So let's just say we have a bunch of these lazy column items, and we need to determine if all of them added up together are greater than the lazy column visible to the user. Now what this ultimately tells us is that the user has to scroll to get to the bottom of the last lazy column item. And to do that, we can just do some simple code like this. Now, again, another hacky thing is I had to define the item height. You can actually see I define it here on the card. But I defined the item height, right? And then to get the total item height, I went note list.size times item height.value. Now in this case, essentially if we had no values on the initial load, this total item height would be 0, right? So we'd say, and then we have a variable called user can scroll, and we'd say the total item height, which is 0, and then is greater than the screen visible to the user, which in that case is false, which would mean the user can't scroll, right? But if we had something like this, we'll just say 2, 2, 2, let me just put a comma there. Let me just copy this, let's put that there, right? If we had something like this, then the user can scroll would be true. And then the only thing that really differs, say from the previous, is that we have this little check here, right? Again, we have item, we have our circular indicator, then we have this if user can scroll, and so it's going to run the launch effect, and then if the user can scroll, right? This is only going to get rendered, right, once we're at the bottom of the list, once we're at the bottom of this lazy column of all these items. And essentially, if the user has had to scroll to get there, so if user can scroll, we make our network request, right? We have that delay to simulate a network request, and then we add everything. And then one sort of bug I have right now, and but we'll work on it in the next tutorial, is you'll notice like what happens if we're left with something like this. So the user, this would be false. So if user can't scroll, right? So that would be false. Then there's going to be no network request. You'll notice that this circular progress indicator is still going to be shown. We'll fix that in the next tutorial, mainly because we'll be storing this notes list inside a view model, and we don't need the launch effect, right? So essentially we could delete that. We could delete it, and then we're just going to, let me just delete this here. We won't have this launch effect. So we could delete launch effect. Then we just put this circular progress indicator inside here like that. So pretty easy fix, but we'll save that for the next series or the next tutorial. Right, with that being said, this is my very hacky solution to the endless scrolling, but nonetheless it seems to work, and I will see you in the next one.